length of the chapter, you will understand triangles, area of triangles, perimeter of triangles, quadrilaterals, square, rhombus, rectangle, parallelogram, trapezium, polygons, and circles. So, first let us see categorization of figures. So, in the topic figures, we have two types of figures. Rectilinear figures. So, rectilinear figures are the figures that are formed with right segments are called rectilinear figures. Examples: triangle, square, rectangle, and other polygons. Next, we shall see curvilinear figures. The figures that are formed with both right segments and curves or only curves are called curvilinear figures. Examples: circle, semicircle, arc, sector. Now, let us talk about triangles. So, what is a triangle? A triangle is a closed figure bounded by three straight lines. Mathematically, it is denoted by the symbol T. The point of intersection of sides is called vertex, denoted by uppercase letters A, B, C, and so on. And the sides are denoted by lowercase letters like A, B, C, and so on, corresponding to its opposite vertex. Altitude or height of a triangle. It is the length of perpendicular drawn from any vertex of triangle to its opposite side. Here is an example. Base of the triangle. The side to which the perpendicular is drawn is called the base of the triangle. Now, let us talk about the classification of triangles. Triangles are broadly classified into three types, which are: type 1. A triangle is classified based on the lengths of sides of the triangles. Type 2. The triangles are classified based on the angles present in the triangle. Type 3. The triangles are categorized based on the angles and the sides in the triangle. Types of triangles based on lengths of sides. So this is type 1, and such triangles are based on the lengths of a side of a triangle. They are classified into three types. They are scalene triangle, isosceles triangle, and equilateral triangle. So, first let us see about scalene triangle. If all three sides of a triangle are of different lengths, then the triangle is called a scalene triangle. Then let us see isosceles triangle. Isosceles triangle is a triangle having two sides of equal length is called an isosceles triangle. At last, let us see equilateral triangle. A triangle having all three sides of equal length is called an equilateral triangle. Now, type 2. Types of triangles based on the angles present in the triangle. So, based on the angles in a triangle, they are classified into three types, which are acute angle triangles, obtuse angle triangles, and right angle triangles. For the first one, let us see acute angle triangle. A triangle with all three angles acute, which is 90 degrees, is called, which is less than 90 degrees, is called an acute angle triangle. Example: in a triangle ABC, we have angle A 60 degrees, angle B 45 degrees, and angle C 75 degrees. Thus, it is an acute angle triangle. Next, let us see about a right angle triangle. A triangle is called a right angle triangle if the measures of one of its angles is 90 degrees. For example, in a triangle ABC, we have the angle B, which is of 90 degrees. Next, let us see obtuse angle triangle. A triangle is called an obtuse angle triangle if one angle measures more than 90 degrees. Example: in a triangle ABC, we have the angle B, which is 135 degrees or more than 90 degrees.
Sir, can you draw the figures example figures?
So, for example, for an acute angle triangle, so this is an example of an acute angle triangle. having all sides and diagonals equal, and each angle measuring 90 degrees. An example of a square: rhombus. A rhombus is a quadrilateral having all sides equal, but diagonals are not equal, but are perpendicular to each other. An example. The next one is rectangle. A rectangle is a quadrilateral having pairs of opposite sides parallel and equal, each angle measuring 90, and the two diagonals are equal in length. This is an example of rectangle. The next quadrilateral is parallelogram. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel, and thus it is called a parallelogram. The two diagonals which come in the parallelogram are not equal in length, but they bisect each other. This is an example. The next one is a trapezium. A trapezium is a quadrilateral having one pair of opposite sides parallel. This is an example. And finally, we have a common quadrilateral. A quadrilateral is a figure whose sides are not equal and not parallel. This is an example. So, we have discussed types of triangles. Now, let us discuss about types of quadrilaterals. Type 1. The four sides are not equal. Some examples of the quadrilaterals of type 1. Type 2. Opposite sides are equal. These are some of the examples showing a parallelogram and a rectangle. Type 3. All sides are equal in the quadrilateral. For example, a square and a rhombus. Now, let us go deep into the topic square. Now, for example, let ABCD be a square. Such that AB is equal to BC is equal to CD is equal to DA, which can be considered as A centimeters, and where BD is the diagonal. So the area of the square is side into side, or we can, since we have kept A for a side, we can say A into A or A square. Or we can use the formula half of the diagonal BC multiplied by diagonal, or we can say half into diagonal square, and the perimeter is sum of all sides. Now let us talk about rhombus. Let ABCD be a rhombus. Here AC, which is diagonal 1, and BD, which is diagonal 2, and the area is half into the product of the diagonals, and the perimeter is the same as the square. We just have to, it is the sum of all sides. The next quadrilateral, which is the rectangle. So an example, let ABCD be a rectangle. Here AB is equal to DC, which we can take as D. So which we can take as B, and BC is equal to AD, which we can take as A. And the area of these triangle is length into breadth, which is BC into DC. And the perimeter is the sum of the all sides, which is A plus B plus A plus B, which we can write as 2 into A plus B centimeters. The next quadrilateral is the parallelogram. Let ABCD be a parallelogram, where AB is equal to CD, which we can take common as B, and BC is equal to AD, which we can take it as A. between the two parallel sides or bases is called altitude or height. AC divides the trapezium into DAC and ABC. So area of this particular trapezium. So the area of DAC plus the area of ABC, or we can say this as half into AB into height plus half into DC into height. Perimeter is sum of all sides of the trapezium. Next, for a common quadrilateral, let ABCD be a quadrilateral, which means that AB is not equals to BC and not equals to CD and not equals to DE, where DL is equal to height 1 or the altitude or perpendicular, and DM is height 2, the altitude is the next altitude or the perpendicular, and area of the quadrilateral is half into length of diagonal into sum of the lengths of the perpendiculars or the altitude, which is the formula derived from this is half into AC into h1 plus h2 square centimeter. So polygons. Let us talk about another topic which is known as polygons. So what is a polygon? A simple closed plane figure formed by 3 or more line segments is called a polygon. A regular polygon. All sides of a polygon are of equal length. Such a polygon is called a regular polygon. The line segments are called the sides of the figures. Each endpoint of a side is called a vertex of a polygon. Note, the minimum number of line segments required to form a closed figure is 3. So here are some examples of a polygon, which is triangle, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon, pentagon, heptagon, and dodecagon. Now, let us talk about circles. So, what is a circle? A circle is a plane figure contained by a line traced out by a point which moves, so that its distance from a certain fixed point is always the same. The fixed point is called the center, which is denoted by O, and the bounding line is called the circumference. So, here is an example. The distance between the center and any point on the circumference is called the radius, denoted by R. This is the radius. Now, next, let us talk about the chord of a circle. A line segment whose ends lie on the circle. A chord passing through the center of the circle is called its diameter. Note, the diameter of any circle is its longest chord. It is very clear that the diameter of any circle is twice its radius. That is, B is equal to 2R. Now, let us talk about the area of a circle. The area of a circle is pi into r square, where pi is a constant which is equal to 22 by 7 or 3.14, and r is the radius. Perimeter of a circle. Perimeter or circumference of a circle is 2 pi r centimeters. Now let us talk about semicircle. A semicircle is a figure which is formed by cutting the center of a circle along its diameter. Its area 1 by 2 multiplied by pi into r square, and the perimeter of circumference is pi r plus 2r. Thank you.
Thank you, ma'am.